Oh yeah, well, Mike said I'm here with Rob Bellinger from Olympus, and this is the OLS4100, and this is a microscope, is that right?
Yes, it's a laser scanning confocal microscope to be exact. It's a precision measuring tool capable of very high resolutions and high magnifications as well. It's statured in the R&D and quality control type areas for its use. Some of those markets range from semiconductor to aerospace to medical device, even down to forensics and larger type material samples. So it has a broad range of mags for larger samples all the way down to your very small semiconductor type samples.
You said this is both laser and optical?
Correct. So it utilizes a laser for the higher resolution imaging and to place all the Z points to create three-dimensional images. It's a confocal tool, so that means it takes very small slices of focus and renders them into a all-in-focus three-dimensional image. When it does that, it captures all the height data as well. It does also incorporate white light color imaging that can be overlaid on top of the standard image to give you some more depth perception to the image to see if the defect was a certain color type or something of interest that you were looking for.
And I believe you said this is really high, or capable of really high magnification, so that's
correct.
Optical magnification, I'm assuming.
Optical magnification down to almost 50x, all the way to over 17,000 times magnification.
And that's optical, not digital.
Optical magnification. Okay. And it's also capable of very high resolution, so 10 nanometers in Z to measure very small surface structures or surface roughness. And it's capable of doing three-dimensional imaging, so we can measure steps, we can measure volumes, and all of that different stuff. The new user interface with the 4100 makes use as simple as possible. So most people that have ever ran any kind of microscope can walk right up to the tool, quickly move around their sample with the live color imaging mode, of course, and then it's just a simple button push of acquisition. With the new software on the 4100, we're capable of doing ultra-fast scans. So single button click generates a smart scan feature. So this is going to have the tool setting all the parameters for you. Brightness, the set points for heights and your focus.
This is kind of like a quick pre-scan just to kind of see where...
Correct. A real quick pre-scan, see the brightness levels, see the points of focus to where it needs to scan through to take the actual image. As soon as that completes, it'll go through and take its normal scan, capture all the high resolution image, and then it'll capture a color scan as well, since we selected to capture color on this.
Okay.
So that was a laser scan. It's very quick. And then it goes through and captures a color.
Is it scanning the area that you're visually seeing, or?
The area that you're visually seeing, the tool also has the capability to do stitching. So you can set a large region of interest and it'll go through and scan the entire three-dimensional region of interest for stitching.
And stitch it together.
Yes,
okay.
correct.
Right.
So now that it's done, you'll see that it presents a complete in-focused image for you. We can go to the workflow across the top. We set the measurements, and we're capable of displaying all the different imaging techniques that it captured. We have bright field color imaging. We have the bright field laser imaging. We could have also selected to do DIC imaging, which is differential interference contrast, that brings out more features on the surface. We can also render in 3D. And
so when you were just doing the scan just now,
correct.
That was actually a 3D scan.
That was a 3D scan, that quick. It went from bottom to top of focus and captured all the data for us. So not only did it capture the three-dimensional data and height, it captured the true laser image, and it also captured the true color image that we can overlay on top. This is our 3D image. We can zoom in and rotate around. And if you see this red line here, this is our line profile. So down at the bottom here, we have our line profile for height data.
Okay.
So this brings in the measurement side of the tool. It can do profile measurements for height and step and cross-sectional area. It can do line roughness measurements, where we can measure some of this tiny little peak roughness on the surface and get your quick roughness measurement. This tool even has an interface to do large area line roughness scans as well. Surface roughness, so if you want to select an entire area on the surface and get the roughness information. And we take all kinds of geometric measurements, like circle-to-circle measurements or out-of-field of points measurements.
You can do volumetric measurements as well?
All kinds of volume measurements for depth, like this scrub mark. If you wanted to know the volume that was removed from it, you can measure what's left and what was removed and get the difference between. We have particle analysis measurement, and the tool is also capable of doing film thickness measurements. for transparent optical
I was going to say,
films.
yeah. So yeah, for transparent films, you could determine you actually can
the
determine where
thickness.
the top of the film is. And
Yep, and the tool with the new multi-layer function will actually scan through and display both layers independent of each other, the optical layer and the solid layer that's below it, maybe a metal surface or something. And if you know the refractive value, you put that in, it tells you the thickness without having to cut it in half.
How's it determining that? Okay, I gotcha.
Yeah.
All right.
So it can determine the thickness, just like you would see this graph here, you'd see the thickness between two layers. And all of this information, once you capture it, it's single button clicks, capture your measurement value, and then you move on to your reporting at the top here. Another single button click takes all this information, drops it into a predefined report template for you, so you can export these report templates to PDF real quick.
And what kind of accuracy do we have?
So this system has, like I said, 10 nanometers in Z for Z height and depth measurements, and 120 nanometers lateral resolution measurement. It's capable of very high magnifications, and there's 3 lens choices that Olympus actually guarantees the repeatability and accuracy specs on.
What do you mean by guarantees?
So it's very important that a measurement tool that's in especially an R&D fab, that it's guaranteed its measurement accuracy. You don't want to take your measurements and not know if they're right on or if they're a few percentages off. So when the system's set up, the engineers perform test scans on traceable standards, and those guarantees are brought forth on all 3 of the high-powered lenses on here. Since we're an optics company, we manufacture the lenses specifically for this laser tool, and we can guarantee the results from those. So the 20, the 50, and 100x objective are all corrected.
Okay.
And that allows us to spec, guarantee accuracy and repeatability.
And I think you said the market for this really is more R&D. Is that the
R&D, quality control? It's falling into place for inspection on circuitry, backside inspections. You have everything from like forensics, looking at the striations or tool markings, so larger samples can fit under here as well. Medical device, a lot of their circuitry and boards are looking at finite wiring and stuff like that.
Okay. Actually, Christopher, is that a question related to the Olympus here? Okay.
So.
Okay, we have a question. What is the difference between optical and digital magnification?
Sure, great question. So this system is capable of having an optical image just like your normal microscope. So it's limited to the objective. The objective magnifies the light to a certain value. Right now we're magnified about a little over 1,000 times magnification here.
So that's straight optical. That's
straight
just
optical
coming through the lens.
Through the lens,
right.
And normal microscopes are limited by that. When we switch to the laser, it's actually scanning the image now, and the laser can increase its magnification by reducing the scan area without any resolution loss. So this is complete optical magnification. So if I zoom in now, higher and higher the magnification goes, I'm over almost 3,500 times magnification here with the same exact lens, just a smaller reduced scan area, same resolution capabilities, higher magnification. Similar way that scanning electron microscopes get their magnification as well.
Okay. And I think sometimes maybe to address more what the question was about too. Sometimes there's this thing called digital magnification, where you simply stretch it, but you're not necessarily seeing any more detail. You're just seeing
exactly. So if I take
a little closer up, right?
If I take a look at our color image here, we can't stretch white light. We can't make it scan or anything like that, but we can digitally zoom it. So that's what we'll do here in color. Is we can digitally zoom, and now you see the resolution drops off.
Right.
The reason it drops off is the pixels only can cover so much. So you're digitally zooming and you start pixelating your image.
Yeah.
Compare that to the laser, which is going to have incredible resolution.
Right.
So,
and you're saying this is only 3,500 right now or so?
This is about 3,500 times magnification.
And you can go up to 17,000.
With the higher mag lens, the 100x, we can go to 17,280 to be
So
exact.
the laser is actually using the same lens as the optical, is that?
Exactly. Yep.
Okay.
It's the white light and the laser light run through the same lens.
Okay.
It's just the laser has the ability to scan smaller areas and increase magnification.
Okay.
Very high.
So is this you mentioned the interface is looks pretty straightforward. Is this a product that is pretty simple for somebody who was obviously familiar with microscopes and so forth, pretty straightforward for them to get up and learning pretty quick.
Yeah, it's really interesting. The interface is so simple that one time we were set the system up, we hadn't even done setting it up entirely. I hadn't even turned it on, and some user that was in the lab just walked up, sat down, and started getting images. And I walked over and said, well, we weren't even ready yet, but they had picture, 3D image, all done. Yeah. They'd never seen the tool before in their life. It really is as simple as one button clicks for acquisition. There's even wizard functions built into the tool that can guide someone through every single step, setting the sample on the stage, creating the focus, getting perfect focus, setting their magnification. It walks them through every step. So it can be a very multi-use kind of lab where you don't have a high training time put into the tool.
And you said there's a certain amount of automation in here. It isn't a fully automated product necessarily, but
not fully automated for auto detect and find and measure, but it does have the capability of doing auto stitching for large area
or programming,
imaging, and
programming certain areas for go here and measure this, or go here and scan this.
Exactly. Yeah, we call it advanced acquisition, and we can put an origin point and deskew our sample and drive back to a predefined list of 100 points and have it three-dimensionally scan every one of those points. And then after that's done, it can walk through the wizard function of measurements. So it can guide the user to take certain step measurements or volume measurements on all those 100 points.
Okay.
Yeah.
And is this part of a series of products, or is this it?
This is in our metrology group. This is our high-resolution model for our metrology system. We also have a what we call tool makers type microscope, a measuring microscope that's much more manual and low mag. This is kind of a standalone system for its resolution and capability for surface roughness.
And I didn't mean to ask, measuring volume?
Yes, we did.
I don't mean to measure volume. I mean size of the stage and
oh yeah, sure. So this system is our 4-inch stage. It's capable of 100mm tall samples, so you can fit like a Coke can on here if you want to. We also have a 12-inch larger stage version that has the capabilities fitting 12-inch wafers or larger samples.
So same optics, just different
same
stage.
Exact optics, bigger stage.
Bigger stage.
Yeah.
Okay. All right, that's it. Okay, yeah. Rob Bellinger from Olympus and the OLS4100. Rob, thanks you for
thank you again for letting us come in.
Sure.
Appreciate it.
Back